Hello, welcome to week 11. The topic of this week is file handling and command line arguments. We start with file handling. So far, we have used various sorts of, data in our programs. We have declared variables and arrays. We have allocated memory statically or dynamically. But all the data we have always stored in memory, the main memory of the program. The problem is that the contents of memory are wiped out when the computer is powered off. For example, consider keeping students' records. 100 students' records are added in array of structures, and machine is then powered off after some time. And when the machine is powered on, the 100 records entered earlier are all gone. And now you'll have to again enter them if they are needed. Yeah. So we need something more permanent. And here is where secondary storage devices come in, like disk, CD-ROM, USB drives, etc. So a named collection of data can be stored in secondary storage like disk, CD-ROM, USB drives, etc. These are persistent storage, so the data or the information is not lost when machine is powered off. So you can save data in memory. The data that is currently in memory can be saved to files. So data in these storage devices are organized in what are called files, and files have names. So you can save your data in named files. Save your data from memory to files if needed, and that is called file write. You can also read data from file later to memory whenever needed, and that is called file read. Yeah. Organization of a file. So how are files stored in the disk? Yeah. So exactly how it's physically stored is not of interest to us, and those details need not concern us programmers. Logically, we can think of them as a contiguous sequence of bytes. They may not be physically contiguous on disk, but you do not need to worry about that. Logically, you can think of them as contiguous sequence of bytes. The last byte of a file contains a special character, the end of file character, EOF, that indicates the end of a file. Yeah, and its ASCII code is 1A in hexadecimal. So while reading a text file, the EOF character can be checked to know the end. So whenever you read the EOF character, that means that you have finished reading the file, and this EOF character marks the end of the file. Yeah. So there are two kinds of file. Text files contains ASCII codes only, and binary files that may contain non-ASCII characters. Examples: image, audio, video, executable, etc. And EOF cannot be used to check end of file for binary files. These are the basic operations on a file. You need to be able to open, read, write, and close. Mainly we want to read or write. Read from a file and write to a file. But a file has to be opened before we can read and write, and should be closed after all read-write is over. How do we open a file? Well, by the function fopen. So file star is a data type that is used to represent a pointer to a file. So this capital FILE is a structure that holds certain details about files. For example, the mode. We'll talk about modes very shortly. A file can be opened in some mode. for instance, read mode, write mode, etc. So a data structure of this type, FILE, contains information about, for instance, the mode of the file or the location of the file where you are presently reading, and so on. Yeah. Again, details of this structure need not concern us. And file star is a pointer to such a structure. We'll think of it, it's often referred to as a file pointer. Yeah. Now, fopen takes two parameters: the name of the file to open and the mode in which it is to be opened. Yeah. It returns the pointer to the file if the file is opened successfully, or null to indicate that it is unable to open the file. We will soon see an example in the next slide, but let's go over what fopen does. Fopen takes in two parameters: name of the file and the mode, and it returns the pointer to the file upon successful completion, if the file is opened successfully, or null to indicate that it is unable to open the file. So here's an example. So let's say I want to open a file named file.dat. Yeah? So first I declare a file pointer fptr, and then there is this string which contains the name of the file as a string constant. Yeah? So fptr is then assigned fopen file name, w. So fopen takes in two strings. The first one is the file name. The second one is a string. Here it's a string of one character. Here this w indicates that I want to open the file in write mode. I want to write to the file. Yeah. And fopen, if it successfully opens the file, it returns a pointer to file star, a suitable structure that maintains the information about the file, and that pointer is assigned to fptr. And if fopen fails to open the file, it returns null. So in this if statement, it is checked whether fptr is equal to null, and if it is equal to null, then you do something appropriate. So as I said before, the second argument of fopen is the mode in which we open the file. So there are few modes. One is the first one is the read mode, and so in that case you should pass this string consisting of the single character R to fopen. It opens a file for reading and can only read. Now if the file name does not exist, then fopen returns error. And if you instead write R plus, then in addition it allows write. W is the write mode, and it creates a file for writing, and it can only write. Now if a file of the given name does not exist, then fopen will create a file. Yeah. Now here is a cautionary note. This if you open a file in write mode and write to that file, it will overwrite all previous contents of the file. It will write over everything that exists before. W plus allows read also. A, it opens a file for appending right at the end of the file. Yeah. So if you want to add something to an existing file, you should open it using this mode. Opening it in W mode will overwrite its existing content. A plus allows read also. Okay. We'll end this the first video by the exit function. Sometimes error checking means we want an emergency exit from a program, and that can be done by the exit function. The exit function can be called from anywhere in your C program and will terminate the program at once. So here is an example. Here you try to open a file in write mode, and if this operation fails, then you print that error in file creation and you can call exit. The argument of this exit is passed to, the caller, whoever called your program. So exit -1 indicates that you terminate and then return -1 to the caller. Generally, if you argument 0 indicates that the program, there was no error, and non-zero arguments indicate some abnormal termination. Yeah, and if exit is called from inside the main, that is same as or equivalent to, just returning from the main. Okay, we continue in the next video. Thank you.